Good day everyone, my name is Poninder and today we will be presenting about boilers components, particularly evaporator. So we will begin with the outline of my presentation, which is what is evaporator and how it works, types of evaporator, boiler process flow, operating principle, technical design, hydraulic calculation of evaporator, parameters, and finally the summary. So what is evaporator? An evaporator is a device in a process that is used to turn the liquid form of chemical substance such as water into its gaseous form or vapor. The liquid is evaporated or vaporized into gas form of the targeted substance in that process. When designing evaporators, engineers must quantify the amount of steam needed for every mass unit of water removed when a concentration is given. Some common terms for understanding the heat transfer is A equals to heat transfer area, Q equals to overall heat transfer rate, and U is the overall heat transfer coefficient. Next, I'd like to explain how an evaporator works. The solution containing the desired product is fed into the evaporator and passes across a heat source. The applied heat converts the water into the solution into a vapor. The evaporator as a machine generally consists of 4 sections. The heating section contains the heating medium, which can vary. Steam is fed into this section. The most common medium consists of parallel tubes, but others have plates or coils typically made from copper or aluminum. The concentrating and separating section removes the vapor being produced from the solution. The condenser condenses the separated vapor, and then the vacuum or pump provides pressure to increase circulation. There are two types of evaporators. One is the natural circulation evaporator and the forced circulation evaporator. In an evaporator using tubing, after the water begins to boil, bubbles will rise and cause circulation, facilitating the separation of the liquid and the vapor at the top of the heating tubes. The amount of evaporation that takes place depends on the temperature difference between the steam and the solution. So, as you can see, this is the natural circulation evaporation and evaporator, and the natural circulation happens through the density differences that arise from the heating, whereas the forced circulation occurs when hydrostatic heat prevents boiling at the heat surface. So you need a pump. Uh, the problem with the pump is that there will be falling, which is due to the boiling of the liquid on the tubes. Thus, the pump suppresses bubble formation. Next, I would like to pass this presentation to my friend Morgan Kumar. Thank you.
Thank you, Puvin. My name is Morgan and I will explain about the boiler process flow. As you can see the diagram on the left, the diagram shows the boiler process flow which start with an economizer that will send the feed water to evaporator to increase the temperature and change the state to saturated steam. Then the saturated steam will flow to superheater to produce high quality steam, which is superheated steam that goes to a high pressure turbine and leaves with low quality steam. Later, the steam will be reheated to run a low pressure turbine if it is available. If not, the steam will use for different process. And on the right, the TS diagram shows the reheat Rankine cycle as the process flow I mentioned before. And the equation shows the rate of heat transfer that can be calculated using the change in enthalpy from state 3 to state 2. Also, the equation to determine the percentage of heat absorbed in evaporator for 1 kg of steam. This slide shows the simplest animation of the boiler system where the feed water from economizer enter the water drum, then it will flow to downcomer and enter the evaporator by passing through a mud drum or header. Then the mixture from evaporator move to water drum again, where the steam leave to superheater while the water in the mixture recycle again to the downcomer. And this slide shows the diagram of technical design of evaporator that can be normally found in an industry. So these are the views of evaporator at different angle. The A shows the view of front and rear view, and the B shows the left and right view of the evaporator. That's all from me. Now I will pass the floor to Tashan to explain more on the evaporator system, and thank you.
Thank you, Morgan Kumar. So I'll be presenting on the hydraulic calculations of evaporator. So what is this hydraulic calculation used for? So these hydraulic calculations are based on definition of the flow rate of every element for the given and adopted conditions. So as you can see in this table 1, this table 1 indicates the procedure to perform hydraulic calculation to analyze the performance of the evaporator or the deterioration of performance of the evaporator. So as you can see, there are two columns whereby designer's results are being mentioned and the design conditions. So the designer's results should match the actual design conditions to know that the evaporator is performing appropriately, or else if it does not match, then there must be an investigation on the evaporator. So calculations for the design condition is based on thermal calculation made for parameters adopted by the boiler manufacturer and for Garant fuel. Under the existing conditions, the case is considered in which the heat load disposition by furnace height is changed in relation to the design. That is, when the highest temperature zone is located in the upper furnace part, which is also known as the Risen flame, as depicted on the most right of the column. With that said, calculations for real conditions are made for improved quality fuel at a lower heating value of approximately 8373.6 kJ per kilogram. The purpose of carrying out hydraulic calculation, as mentioned, is to locate the jeopardized areas of the evaporator. Next, if there is an increase of water amount in the separator due to the difference in calculations, the circulation pump is required to be installed. Alternatively, a regulating valve can also be installed in the downcomer part of the evaporator. Also, if there's a decrease of steam quality on the evaporator outlet, there could be two reasons. A, which is lower heat quantity given to the evaporator. Next is the increase of latent heat of vaporization. In terms of investigating the quality of evaporator, there are a few factors to consider. The first factor is cavitation effect. So what is cavitation effect? Cavitation effect is when bubbles occur, or there's bubbles collapse on the solid walls in the evaporator, causing increased noise and vibrations, or sometimes loss of efficiency. Next is the absence of flow pulsation, stability of hydraulic characteristics, normal temperatures regime of heating tubes. Last but not least is the absence of circulation halt and direction change. That's all for my part. Thank you.
So I would like to summarize our overall presentation. Thus, boiler works using the fuel of improved quality with a Risen flame in furnace, which is suitable to existing conditions and bring changes to the evaporator working conditions in such manner that the critical heat transfer conditions are worsened. Most of the time, boiler's breakdown was due to damage caused by thermal changes on the support tubes. Increase of inclination improves the condition of the tube, so it is recommended to increase the inclination angle for this part of the tubes. Besides, it would be good to use material of better quality for this part of support tubes. These are the references that we used, the journals, to collect information in order to carry out our presentation. And we would like to thank you and thank our Professor Hussein for guiding and supervising us to ensure that the project was a success. Thank you.